That means if it is a 2 bytes of data, okay, let me record, okay, 2 bytes of data. So 12 into 2, it is equal to 24 bytes of memory locations should be allocated. So here, when I was showing here, so here 0 to 11 means 12 bytes, okay? And all of our integer type, there is no decimal values because it is integer type. It is started with 200 and this has consumed 4 bytes. This is next 4 bytes. So that means 12 into 4 bytes. So almost like if it is a 4 bytes, if integer type of size, that means 48 bytes of memory should be allocated to store the value. So that is how we call it as a homogeneous collection. Why homogeneous collection? It should be either integer type, either it should be a float type, either it should be a character type. If it is a character type, so if it is a 12 data is there, one byte, it will be 12 memory size will be 12 bytes of memory will be allocated. For example, if it's a 8 float with 8 bytes or something like that, if you say 96 bytes will be allocated. So like this, the memory will be contiguous. There is no break here. If your array is there, array means this will be indexed 0, 1, 2, 3. What will be there here? This is started with 200, right? If it is 200 means usually when you represent this array or name, it is a variable name. How much size you want, we are doing that. And if you want to store integer value, I can give integer. Or if it is a character value, I can represent character. If it is a float value, I can represent as a float value. Ideally speaking, what ARR holds is the starting address of that contiguous memory or continuous memory. So what is the contiguous starting address? 200 is the starting address. That means, so ARR is pointing to the memory address 200, and then there will be a subscriptor like 200 into 0. That is the starting point. Arrays always starts with the 0 byte plus 4. When you say subscription 0, okay, 0, the ARR is pointed to 200. Maybe your data storing maybe wall or something like that value. And what is the ARR contains pointer to this. Pointer to this means what is the base address? This is the base address. If it is an integer type, assume that the size is 4 byte of equally. Then what it does? Next element, maybe index is 1 means 200 plus 4. This is the 4. Then next becomes the 204. So there may be, I may store the value, variable value RT. Similarly, if I want to store second item, I can mention here, okay, then plus 4, then it becomes 208. Then it will be value, maybe I will be storing 40. Similarly, at the stage of third, it may be 208 plus 4, it becomes 212. Like this, it is keep on incrementing one by one. If this was character type, like for example, I want to store A, then if you have declared like instead of array told, if you have stored like a character, then it is not like this one. This will be 1 byte. Then only 12 bytes. Then what would be there? 200. The next address will be 201. And here you have to store B or X, something like that, single character. The next character may be, okay, 2. You may be storing C. And here I may be storing X. But next address will be 3. Okay. So that means whenever you are declaring an array is nothing but can hold similar kind of data. It may be character, it may be integer, it may be float. That is what we call it as a homogeneous collection of data items in a contiguous memory. We call it as a array. Array is nothing but it is a group of homogeneous collection of data items in the contiguous memory. That means our destination we are able to derive, okay, as an array, it is a collection of homogeneous means similar kind of items, homogeneous data items stored in contiguous memory. How do you declare this? You are declaring similar to the normal variable like int, float, double, like this. Then you have maybe mentioned the size of the array. So this is what you have to remember. It means that if its float is 4 byte or 8 byte, so automatically this memory will be automatically advanced in that size. Okay. Now let me go here. Okay. Let me understand further. Then decimal point. This is decimal point. This is non-decimal point. This is a character. Okay. So this is what it is representing actually. So this is what, but if you try to store assign, okay, 11th item, it will throw, it will not, this is a runtime error, you can notice. Because it has accommodate only contiguous 20 bytes or 40 bytes. But if you try to auto-accommodate this, then it will not accept, okay? It will accept also. So this is a runtime error, you can see that. So that's why array is nothing but we always should define fixed maximum size, whether you use it or not. For example, if you declare 200, so 200 into assume that 4 bytes, 400 bytes of memory you have utilizing, okay, assume that the 400 bytes, but you are storing only one value. Still this 400 bytes of memory will be wasted. That is the problem with array actually. So array is nothing but if you look at that, this is called index or a subscriptor, and this is the value for an array, and this is the memory address, how it advances, because it is a contiguous memory of an array. So this is how arrays will be stored. So if you look at this one 0, 1, 2, 3, 4, 5, and this is character types. So that's why 200, 201, 202, 203, 204, like this. So this is how arrays will be operating. Any questions here? Any questions? Anyone has questions here? Able to follow at least? Yes? Just tell me yes or no. That's it. Yeah. Athay, do you have any question?
No, sir, that's okay, sir.
Okay, fine. Okay. So now we have understood what is array. Now let us try to understand further. Okay. So we have understood always array name is nothing but a base address. And then we are going to add the value to that. So for example, the student 0 means first value. Student 1 is nothing but second value. Student 2 is nothing but second value, third value. Like this, we can keep on doing that. So it's a collection of similar type of items that's called homogeneous type contiguously in the memory. Now let us understand further. Let me do few programs. Then you will be able to appreciate rather than theory part. Better to go for, let me take one simple program and understand that. Okay. Let me open this. Okay. So let me write. Okay. So now let me write a simple program. Write a program to check sum of input numbers using array. Let me save this. Okay. Array example 1.c, something like this. Now, if I want to check sum of input numbers using an array, this is a simple program. Now, hash include, this is a standard. As usual, you know that, okay, what is standard? So we used to follow. Those who are missed who are on live YouTube session, they can see the previous videos so that you can understand this. This is purely the people who never understood programming. If you follow this for next 2 to 3 weeks, okay, And I believe that you will be capable. Last 2 weeks, whatever we have done, if you just follow those videos, definitely you can appreciate how easy to learn the programming language. Just you have to, the last session also functions, it is the most beautiful concept. And arrays is also one of the most simple and beautiful concept. Just you have to take your time, be cautious and understand, and start typing 1 or 2 programs, then automatically you realize that, okay, coding is very easy job. Now let us move on. Ash include studio.h. So this is the standard line as usual, I said, right? And we written so many times. Now also I'm writing conio.h. We know that what is the purpose of this. And void main. This, you know that this is indicating the beginning of the program. So what is my job? So I want to enter the elements, okay? And I want to perform the sum of this actually, sum of the items. Let me write simple program. Let me read, okay, n, how many elements I want. Then I want to do the sum of these items. Okay, if it is integer sum will be there. How many items I have to create? So if I want to create array size, let me int, array. So 10 item. So now let me add the clear screen here. Done. Printf, enter the limit. So how much array size? But you remember here array size 10, your limit should be within 10. Otherwise, that much memory will not be allocated. And almost if it is your hardware of integer is 2 bytes, it will be adding the it depends actually. The 10 into 2, 20 bytes memory is allocated. Some 64-bit machine and all, it will be allocated 4 bytes. Then it will go to the 40 bytes of memory will be allocated. It depends upon the your process word, but that's why the C is the machine dependent code is generated. Because of that, you cannot take this object code and execute on the other machine, like unlike a Java platform. So whichever the program you are running on which machine, there only you can execute. You cannot carry the object code like how Java can execute it in different machines, compile once and run anywhere. So C is not a platform independent. It is specific to your hardware machine. So that's why. So if it is a 2 byte or a 4 byte, it is taking. So like almost 40 bytes of memory is already allocated. So whether you use it or not, it is wasted. Okay. Now in that I am telling that, okay, I have to tell the limit. How much elements you want to input. So scanf %d ampersand n. So you are reading the how many items you want, maybe 5, 6, 10, but it should be within 10. Arrays always started with a 0, as I showed in the previous the diagram. Now, if you look at this, you got this value, just you are mentioning that enter the limit. Now I have to perform the sum of this, right? Printf, enter the how many items? %d items. So how many elements you have to do that? Maybe n items. So that means enter the 5 items. D is nothing but already you have read the value, and I am showing in the message that you have to enter the 5 items. Let me give the new line so that it should be clear for us. Okay. So we have done new line. Now once this is done, now I have to read it. When you want to read it, how many items? 10 or n items you have to read it. Then repetitive task, what we used to do, while loop or do while loop or for. Obviously, majority of time we will use the for loop. First for, because in one line only I can initialize. Previous program I have shown you yesterday that the 3 lines of code you have this one. In for loop, in single line you can take it. So that's why I will also go with that. Now, if I want to create see, I is equal to 0 or counter, it should start with 0. So I have to declare one more variable called I. But this you can declare like this also. This will work, but it is a C++ compiler. Because of that, it will work. But actually in C, we have to declare everything here only. I is equal to 0. Then I less than how many items? Here 10. So that is like n items because I have read already n items. Then I should be incremented. Okay, we have done this. So what is our objective? You have to read the items and perform the sum of this. Scanf. Okay, %d. Where I have to read? Ampersand. Which is the, here I have to read. Okay, for this ARR. So this is the one change. Counter. So now dynamically I am saying ARR 0, ARR 1, ARR 2 up to how many are there here? ARR n, we are doing that. Now I have read this value. Sum is equal to sum plus I am writing here only. So I okay, ARR 0, I am adding to the sum and I am performing the sum. Then after n completed, printf the sum of %d items in array. Okay, so okay, d sorry n and sum is %d. I am closing this. Now once this is done, writing get ch. Once again we will discuss. So I am not in a hurry, don't worry. So let us, our objective is to how to run the program. So let me F2, control F9, enter the limit. So there is 10 is the maximum limit. I can take 6, enter the 6 elements, 1, 2, 3, 4, 5, 8. Okay, I have done that. And this is the sum, we got it. So this is how the sum of 6 items in an array is 23. Such a beautiful program. So now the combination of for loop and arrays is helping us to minimize the lines. Otherwise, how many, if it's n 6 items, I have to create a 6 items. So always n should be within this range. If you take more than that, memory has already consumed continuously only for to hold the 10 size. If you want to add the 11 size, so it will not work actually. So that's why you should be very careful when you are doing this. For example, if I want to store 8 items, I can write 8. So, okay, so I can perform like this. So for 8 items, it is giving the 60. So this is how we can perform the sum of the n items. So this is from this you are able to understand what is array. Array is the homogeneous collection of here integer type, and what is the maximum size that you have to declare. If you remove this, okay, so there is an error. So it is telling that please specify the size of this. So you have, because it has to allocate a memory in the static memory. So I will show that. Then you have to take on the limit. Then you are performing the sum of the elements items here. So any questions here? Able to follow? Yeah. So it is a simple and straightforward. So we have understood what is array. So if you look at this diagram, so you will be able to appreciate so how the where array will be created. So basically, whenever you are executing the program, so there will be a main memory, right? So RAM. In that it will go. So whatever the, for example, you have written hello world.c. Where it will be stored? It will be stored in the, already in the first session we have discussed. It is stored in the hard disk, secondary storage device. But if you want to execute, it has to load to the main memory. It has to load to the main memory. In the main memory, that has been divided. It may be 128 MB or 512 MB or 1 GB. It is divided, that main memory, in this type of structure. So in this, a local variable declarations and all you can create here, okay, stock. If you want to store dynamic variables, there is a heap memory is there, okay. in data structure when we are learning, and everything we are going to operate through the heap memory. When you declare an array, so array will be having the static data part where it will be kept. So if there is a memory data available here, then only memory will be allocated. Otherwise, it will not be created at all. So that means then your program code will be there. This is how the structure of your array will be stored in the static part. If you go to a concept of the pointers or dynamic structures, then that data will be stored in the heap variable. Local variables will be kept here in the stock as a pointer, and program code will be here. Actually, this is as just a simple information we are talking here actually. So any questions here from anyone? Yeah, Reenaz. So Nabila, so any questions from anyone? Able to follow? Can I assume like that? Yeah. So now let me move on then. Okay. So now we have understood how to create an array. Let me go to do some more programs so that you will be comfortable using the combination of for loop, while loop, and all those things. Also arrays. Let me go here. This is the problem with traditional. Okay. So we have done this. Let me create one more program. Okay. Okay. So now we have to save this this one. So let me write to find the maximum of elements. Okay. Max.c. Now, if you want to write the simple program, max.c, let me maximum on this one. As usual, the program is find the maximum of item stored in array. So this is the logic I have to find out. So what I have to do now, let me create as usual. I believe you people know now because we have typed this header or a library so many times. Hash include conio.h void main. So we have understood here. Okay. Now we are declaring the variable int n array. I can create 10 or 20. Usually I will keep 10 items. Then I wanted to find max. Okay. Maximum item in the array. So this is how we have done. Then clear screen. So once this is done, now let me enter the n item printf. Enter the n item. So limit, okay, I have to understand. Scanf %d ampersand n. I am doing this very simple. Now once this is done, so I have to read the enter the item. Okay, we have entered the item. Then if you want to execute this, okay, if you want to execute this, now I have to read this value in an array. So printf enter the n items. So instead of n already I have read. I can give the number also. That is nothing but n. Now once this is done, okay, for, so I want to use I. Okay, so I integer, I is equal to 0. I less than n, I plus plus, because array starts with 0. Now I am reading this value. scanf %d ampersand e of array of I. So I am reading all the values. So I am able to read all the values. If it is only one line, this is also not required. For one line, I do not require this. So I am able to read it. Now the next, this one is, so I have to write the logic for what is the maximum number stored in array. This is my object. So how do you do that? Let me take max. I will imagine that, okay, I can give 0 or array first element itself. I assume that this is a big item. So I can do many ways. Okay, I can store negative value or minus 100, something like that. Instead of that, let me store first item value itself is a maximum. I am assuming that the array first element itself is maximum. Now, once again, I am writing the logic for this. I is equal to 0, I less than n, I plus plus. So let me do this. I have to write the logic. If ER of I array content is a maximum, then assumed value. What is assumed the value here? So we assumed first element itself is a maximum. Assume that first element is maximum, but array content is more than the current item. Then what you have to do? You have to swap it. Okay. Array I should assign the value to this as if this is the maximum. Now, once this is done, everything is done. So I will complete the for loop. By the time end of this, I will be having the maximum items. Maximum item in an array is %d, that is nothing but max. So now I will give the get ch and this one. Let us see this so that you can appreciate the program. So there is a syntax error, library control F9. Another error is it is telling that it is missing something. Yes, function is missing this. You have to read the value and see that unexpected. So I got it. So what is this? Enter the n item. So how many, what is the size, maximum size? I am taking 8. Enter the 8 items. 1, 3, 2, 2, 5, 21, 9, 1, 2, 30. So maximum item is 2222. This is the output in array. I have stored 8 items, and among them, which is the biggest item, so largest item. So that's just to understand how usually we can use and store and do the maximum marks code. Who is the topper? Okay. So all these things, if I want to do that, if we store in the array, I can use this type of logic. So what I have done here, I am assuming that 0th element of array is the maximum item. I have initialized it here. Then after that, when you went to the loop, I am just checking that, okay, which is the maximum element. Maximum element is nothing but array of I is greater than max. Okay, the array content itself inside whatever that is there, bigger than max, then it will be we are assigning this value. So if you just to make you people to understand better, let me take, okay, what I have done is array of 10. This is the maximum size I have allotted as an array. So in the static memory, it has allotted, assume that if it's 4 bytes, 40 bytes of memory is allocated. Then I read the n value. So in that n value, I have given 8 size. That means only it is filled up to 8 items. That means 32 bytes. Rest element will be some unpredictable value will be there. Then what I have done is, so when array has, assume that array has 0, array has 1, array has 2, array has 3, array has 4, array has 5, 6, 7, 8. So we have all this item. So the base address will be array address. It may be holding. So this is nothing but you have stored 10, okay, 20, 30, okay, is equal to 40. Assume that you have array of 9. So 0 to 9, this one is there. So assume that I have stored 2, 1. So I have stored here some number 3. So then I have done 6. So I may be having 8. But this will be unpredictable. I don't know what is the value here. But till this time, we have n is equal to 8. I have stored this value. Then, so array, there is nothing but base address. Base address in the memory, it may be 1000. So 100 or 1000. So 100 we make 100. Then this will be, memory size will be, and if it's a 4 byte, if you take in this current machine, 4 bytes, then it will be 108. Similarly, this may be 12. This may be 116. And this may be 120. And this may be 124. And this may be 128. So what is the starting address? When you see array, it is holding 100 is the address. This is nothing but it is pointing to this. So that is nothing but it contains this value 10, 20, 30. We are assigning this and we have performed the sum of this n item up to this. Assume that if you have declared array size is like a 10, instead of that, you wanted to go for n is equal to 11. So this is wrong. So because it can hold only maximum 9 items, which is fixed and contiguous memory. So that was the advantage to use the arrays. So we have understood what is arrays, what is the collection of homogeneous collection of items. So that means it is very simple program. We have understood how it is working. The logic what we have made is here. So first element itself, I assumed that the 10 is the biggest because I have pointed to 0. Its value is 10. Next, I have compared, I went to first. So whether the max is greater than this. If it is not, this content is greater, then max is, I am going to update this 20. Similar, next, once again, I compare, then I am updating 30. Then I am updating 40. But when I went to the array of 4 comparison, 40 itself is big, it is not modified. Then once again, it is compared with this 3, but 40 is more, so I am not modified. 6, okay, 8. For example, this is 100. So it would have been the array of 7 value will be assigned to a 100. And that's why max will be having always the biggest item. Biggest item. So this is how the arrays are working. Similarly, if you want to make a smallest item, just instead of the big, you have to make it as a reverse the logic. Reverse the logic in the sense, instead of comparing the max item, you have to do the smallest item. That's it. So you do not require to, just if you have to reverse the current logic condition, and that will be a biggest. Okay, so here's some, I think. So this is the program. So we have done. If I want to, instead of this, I want to make this as the minimum. Instead of maximum, I want to know minimum of items stored in array. So then instead of this, I just modify this minimum. So enter the n items. I read this value. So logic to minimum value number stored. So here this is nothing but minimum. So I will also assume first item itself is minimum. So here I will make this as minimum. Instead of comparing this, I will reverse this logic. And here I will make this as minimum. And I will, this is nothing but minimum item. So I have saved. Now let me run this. So that means this one, F2. So there is something is missing. Max, still max is there. Yeah, here minimum. So just simply I have modified here. You have to save it. So I have done this. Let me save this. Control F9. 6 items. So 10, 1, 2, 3, 34, 5. So 1 is the minimum item. So once again, if I want to do the same thing, Control F9. So I wanted to make the 8 items. So let me write 12, 33, 44. Let me make 45, 3, 44, 55. So if you see that 3 is the minimum. So this is how I can write very simple program using the arrays. So you can do that and you can identify the maximum item also we have seen, smallest item also we have seen. So in the next session, I will do almost 7-8 programs, which is it will make you to comfortable to work with arrays, loops, and decision-making statements, such that you can practice on functions, arrays, looping constructs, and some variables. So next session, dedicatedly we will use whatever we learned till now. Okay, we use it. And completely on Monday, we will discuss. So usually, as usual, Monday to Thursday, we have regular sessions, okay? Weekly 4 days. And next session will be on Monday. So we'll discuss on that. Any questions from anyone? So any questions, please? Yeah, so all of you are able to follow?
Yes, sir.
Okay, so next week.
Sir,
Yeah.
if you give the students some assignments, I think it will be better.
So, yeah. So I will send it. I will send it to you. You can distribute. Also, I will send
Okay, sir.
the lab set whatever we have covered till date. Okay, just you
Yes,
can.
sir. Yeah. Okay, sir. Thank you, sir.
Okay, thank you. So next session will be on Monday. Okay.